Welcome students. The next practical which we have to study in class 10th is the study of path of light through glass slab. Glass slab is a transparent glass medium. This is the glass slab. We have to study how light travels through this glass slab. As it is made up of glass, it is another medium. And when light enters into another medium, a phenomena occurs which is called refraction of light. We will discuss it. The aim of the experiment is to study the path of light through glass slab and to find angle I, which stands for angle of incidence, angle R, angle of refraction, angle E, angle of emergence, and lateral displacement. For finding these, we have to use a glass slab, some board pins, pencil, scale, and protractor for measuring the angles. Very simple set of apparatus used for this experiment. Now the information which you should know before conducting this activity, you should know what is incident ray. Incident ray is the ray which falls on glass slab. The ray which is falling on glass slab is called incident ray. Refracted ray, the ray traveling through slab. After falling on this slab, the ray is going to travel through this medium also. So the ray traveling through this medium, through this slab, is called refracted ray. And after traveling through it, it is going to come out again because it is transparent. So that ray will be called emergent ray, the ray coming out of the slab. Next, you should know what is angle of incidence. It is the angle between incident ray and normal at point of incidence. The point of incidence is the point where incident ray strikes the glass slab. See this diagram? Things will be more clear to you. This is outline of the glass slab. This I have drawn dotted line, a normal. Normal is basically a perpendicular on the surface. This is incident ray coming towards the slab. This ray is refracted ray which is passing through the slab, solid line. And this is emergent ray which is coming out from the slab. Now this is angle of incidence, angle I. It is between incident ray and normal. Angle R, which is angle of refraction, it is between normal and refracted ray. This is angle of emergence, and this point is point of emergence. So normal at point of emergence and emergent ray, the angle between them is called angle of emergence. And we will see incident ray and emergent ray, they are parallel to each other. If this slab had not been in between, this ray, incident ray, would have taken this path because light travels in straight line in a medium. And the distance between this incident ray and this emergent ray, this xy, this is called lateral displacement. So we were talking about angle of incidence. Now they are clear to you. It is angle between incident ray and normal at the point of incidence. Angle of refraction, the angle between refracted ray and normal, again at point of incidence. Angle of emergence, the angle between emergent ray and normal at point of emergence. Next is lateral displacement. It is the perpendicular distance between incident ray and emergent ray. Now, what is refraction? We have used this word so many times. Refraction is an optical phenomena. When a ray of light falls obliquely, obliquely means which is not perpendicular. So, when a ray of light falls obliquely on another medium, it changes its path. Who changes its path? Ray of light changes its path. And this happens due to change in speed of light. Means when light is traveling in air, it has another value of speed. When it is passing through this slab, it has different speed. And due to this difference in speeds, the path of light changes. See in this diagram, this incident ray, it has changed its path along this line. Then again it is changing the path as there is change in medium. The basics are clear. Now we are going to use the apparatus and see how we are going to draw the diagram. This is our drawing board, white sheet, fixed with the help of thumb pins so that it does not move. Now, first put the slab in the center of this . Now I have drawn the outline of this slab, making it bold. Now I take a point here. This is point of incidence. At this point of incidence, I am drawing a normal with the help of this protractor. (90°). This is our normal at point of incidence. Now I am drawing incident ray. I am taking angle of incidence as 30°. Angle of incidence 30 means this point. You are saying it is 60, but we have to measure this angle. So it is 30. This is our incident ray. Now we will put two pins on this incident ray. They should not be much close to each other. Now I will put the slab on this outline part. So this is incident ray traveling, falling on this surface. This is our first refracting surface. Now I am going to see through this refracting surface the second one. For this, we have to see through this slab and we'll have to arrange other pins in the direction of these two pins.
पहले आप लगा दो फिर बताओ।
Now all these 4 pins, if you see through this surface, they are appearing in the same line, and they should appear in the same line. Right? They are in the same line. Okay. Now I am removing this pin and marking this point. This pin also, removing the slab, naming them as P1, P2, P3, P4. Now I am joining these points, straight line. This is our emergent ray, and this point is point of emergence. Now connecting these point of incidence and point of emergence, we are seeing this bend in the path of light. At this point also, we are going to draw a normal. Normal is basically imaginary line, and imaginary line should be dotted. So this is normal 2, this was normal 1. I am writing it point of incidence. This side point of emergence. This angle is angle of emergence. This is angle of refraction, and this is angle of incidence. Arrow should be there to show the direction of path of light. Now we have seen the path of light through this glass slab and naming these. This is incident ray, this ray is refracted ray, and this ray is emergent ray. Now I am producing this incident ray these two rays, they are parallel to each other, and this distance x y, this x y is lateral displacement. You should measure this lateral displacement by using this scale. Wow, it is 1 centimeter. Is it visible? 0, 1. So I am writing it 1 centimeter. Now we are going to measure the angle of emergence. Angle I we had taken 30 degree. Now our angle of emergence should also be 30 degree.
changes.
Look, this is 30 degree. Is it visible to you? I am taking the other protractor. This is 30, right? So we have found that angle of emergence is also equal to 30 degree. What can you say about angle of refraction? Will it be 30 or less than 30? It should be less than 30 as the ray is bending towards the normal. So it is nearly slightly more than 20, 1, 2, 1, 2, This is 22 degree. Angle R is 22 degree. So this was our activity. We have proved that angle I is equal to angle E, 30 degree. And due to this equal angle, incident ray is parallel to emergent ray. And this distance between these two rays is called lateral displacement. It was found 1 centimeter. Hope you have understood this activity. Thank you very much.